Okay, welcome to Notes 26.3. You'll be in your Springboard book again, as you can see. So good news is today is a lot shorter, so I hope to go a lot faster. Today's a lot of reading, though, on this first page. We want to continue with inverse functions. So today we'll talk about cube root and cubic functions. But it's important to highlight. I'm going to go through this. Normally I don't, but I am going to go through this today. So it says, so far you've graphed and found the inverse functions of linear, exponential, because the inverse of a linear is a linear, right? Inverse of an exponential is a log, right? Inverse of a log is exponential. Inverse of quadratic is square roots. Those go together. So exponential logs go together. Quadratic square roots go together. And so today we're going to study cube root and cubic functions. Those go together. Okay, linear, exponential, log, and square root functions always have inverses that are functions. And then it says quadratic functions have inverses that are functions only if the domain is restricted. Otherwise, the inverse is a relation. And so let's review what's a relation. That was yesterday. Relation is what? Set of ordered pairs. Relation just is like a scatter plot, kind of just random points. All right, any function that is one-to-one, this is important as well. A relation and a function that's one-to-one will have an inverse that is a function. If a function is not one-to-one, the inverse will only be a relation. So remember, a one-to-one function is when your original is a function and your inverse is also a function. That was one-to-one. That's important. You will see that in pre-cal as well. Okay, now let's explore cube and cube root to see if the similar patterns exist. If we can determine whether a given cube or cube function is one-to-one, then we will know whether the inverse is a function. Okay, so study the graphs. It says each cubic graph in the bottom row is the inverse of the cube root graph in the top. Think of the graphs in the center are translations of the parent function. So remember I said like here is what? The cubic function, right? And then it's the same picture. It's like I can use the same tool. And there's a cube, like there's y equals x cube. So y equals x cube, y equals cube root. They're the same function. So this is the parent function. And this one just went up 4. And so you can see this one went right 4. These go together. And then this one went right and up, right and up. So what did this one do? This one went right 3, up 5. This is one went right 5, up 3, because x and y switch, right? So that's really important to know. Like you can tell, like this is positive, went up. This is to the right, positive. So it still matches. So everything in this box is good to know. It's good information to go back to. So let's highlight that. All right, almost done. Next page. All right, Alex says that the cube root function and cubic functions are not one-to-one. Are the cubic, wait, my picture is different than this one. Oh, well. It says, is Alex correct? Alex says that the cube root functions and cubic functions are not one-to-one. Is Alex correct? No. They are one-to-one. Because you can tell that this is, I think I'm on, what is that? All right, so this, you can tell this one is a function and this is a function. Because for every x, there's only one y. For every x, there's only one y. Because it says Alex says the cube root are not one-to-one. No, because they're both functions. Give me for a look for a second. Okay, it says give the domain and range for each of the functions and their inverses. You may write in general statement, describe the domain and range. Okay, so what is the domain and range of each? Domain is all real numbers. Range is all real numbers. Or you can say negative infinity to infinity, whatever you like. Okay, and it's the same, right? You can tell by looking at the picture that double arrows means one or both have to be all real numbers. You can tell from left to right, it's all real numbers. From low to high, it goes on forever. Let's see. The inverse of a translated cube root function is a translated cubic function. Since finding inverses involves interchanging the x, y values, The vertical and horizontal translations are also interchange. And that's what we just talked about a second ago. So we just did that. So this is also important. Okay, and that's exactly what I said a second ago over here. When we said like went right 3 up 5, well here it's interchangeable. It's right 5 up 3. So that's what they're saying there, just interchange, which makes sense because X and Y switches. Here, find the inverse function. Well, this one is what, right 6 up 1. Okay, so if you switch X and Y, solve for Y, I trust that you can follow this, then this will be what, right 1 up 6. So you can see how it interchanges. So that makes sense. So you can follow the steps. I think you guys can get that. Okay, not all cube root or cube functions are translations of their parent functions, so we need to examine them as well. Okay, find the inverse of this function. So what does this one do? This goes left 3, right? So find the inverse. So let's find the inverse. So let's do A over here. So let's be X equals cube root of Y plus 3. So cube both sides to get rid of the radical symbol equals Y plus 3. So X cubed minus 3 equals Y. So there is the inverse, right? And this one does what? Down 3. And then for some reason I skipped this one because I think one example is enough. I bet you're happy about that. Okay. Then it says use a graphing calculator to investigate the graph cube root of x squared plus 4x in a standard 10 by 10 viewing window. Sketch the graph. Is f a 1-to-1 function? Why or why not? Will this inverse of s be a function? Let's find out. So let's type that in. You can go to your math button, I believe. And there's a cube root button there. Okay, here is what I got. So it looks like that. So my picture is something like, I don't know, because that x squared puts a little extra loop in there. Sketch the graph. Is f 1-to-1? Why or why not? Will the inverse be a function? So is it 1-to-1? We can tell by looking at the picture. For every x, is there only one y? No, not when you go. Is for every y, is there only one x? So no, not 1-to-1. Okay, sketch the graph. Is if s 1, why or why not? Will the inverse of the function be 1? So no inverse will not be a function. Okay, so I can tell by looking at this picture, like, is this a function? Yes, this is a function. But 1-to-1 means, is the original a function? Yes, but is the inverse a function? Well, when I go like this, it hits twice, right? So it fails the vertical line test. So since it fails the vertical line test, this is not, the inverse is not a function. So since it fails the vertical line test, the inverse is not a function. So because of that, therefore it's not 1-to-1. So 1-to-1 means that this has to be a function and the inverse has to be a function. So I can test it out and see that it fails. And so I know the inverse is not a function. So therefore it's not 1-to-1. Investigate the cubic function. Okay, use your calculator. So let's do that one really fast. So type it in your calculator. X cubed minus 6x squared plus 8x plus 5. Okay, you can tell by that one. That one looks like this. Is this a function? Yes. But it says sketch the graph. Got that. Is G 1 to 1? Hopefully you're going to say, again, no, not 1 to 1, right? And well, the inverse, well, obviously the inverse won't be a function. No, the inverse is not a function either, but as you can tell, it's going to repeat. So when I turn it around, your x will repeat. So if you turn this, well, if you're reflective of the line y equals x and switch x and y, your x will repeat. So for every x, you'll have more than one y. That's the reason why. But we can check it really quick with the testing. So that is good. All right, and I wanted to go back really fast. Make sure you guys understand this part when it comes to square and square roots. So I do want to go back up here though really fast. It says cube root and cube root functions are not one-to-one. They're referring to this over here is what I was going off of. Like, are these all one-to-one? These are all one-to-one because they're simple translations and they're simple off the parent function. So it's a little confusing. So it says, because I know that they're not always one-to-one, but I just says cube and cube functions are not one-to-one. Is Alex correct? I went based off of the pictures on the other page. That's why I paused a second ago, because I know that they're not always one-to-one, but these are all one-to-one. You can tell they're all one-to-one. So this answer is based off the previous graphs, but we just gave some examples here that not all cube and cube root functions are one-to-one. So from previous graphs. That's why I paused a second. Okay. All right, last little thing. This is just a review. Okay, so we already went over this because I showed this here. Like, domain of a cube root is all real numbers, domain and range. And then here is x, y equals x cubed. So you can tell it's the same picture. I think you guys are good with that. But I do want to go with this really fast. Okay, so this is a quadratic, right? That is a function. The inverse of this will look like this, right? I'll just, like, we can do, we'll move it up if we want. So like 0, 2, 2, 0, right? So there's 0, 2. That is a function. The inverse of it looks like this, okay? Those are inverses of each other. I got two of them. Those are inverses of each other. But the question is, this is a function, yes. Is this a function? No. So if this is the original shape, is it one-to-one? And you would say no, because this fails the vertical line test, or it's because for every x there's more than one y. So yes, these are inverses of each other, but no, it is not one-to-one. Okay, then yesterday's lesson was about, okay, is this a function? Yes. But then, is this a function? No. Or no. But then it says, what can you do to this function that when you, when you restrict it, it is a function. So that's what yesterday's lesson was about. So here's a function. We'll say y equals x squared plus 2, right? Okay, this is the function. So what do you have to do to this that when you do the inverse, it is a function? So what I did was yesterday is restrict it. So you're literally doing this. You're literally cutting it in half. Oh, I may not. There. So therefore, I just want one particular side. So x comma x is greater than or equal to 0. So if I restrict that, then when I go to what, that's the right side, when I go to do the inverse, it'll look like this. Does that make sense? Sort of, kind of. Okay. So therefore you have to restrict it, right? So you want to restrict it like that. So that's why you do that. So when I do the inverse is a function. And then I think yesterday was something like this. It was like, I think that was the biggest thing. So anyway, so I hope that helps why you have to restrict it. Hope the visual makes more sense, why you have to be careful what the question is asking. So be careful that you guys are reading your questions on restrictions, not restricting, inverse, not inverse, one-to-one, what all that is. So if you need help, contact me in office hours, and I will see you soon.